In the last session, we had a look at the WIRESHARK tool. We request that you go through other sources for understanding about WIRESHARK, because we will be using this WIRESHARK tool extensively. Sometimes if you are not going to use command line, you can actually use the WIRESHARK tool to achieve the same effect as what we do in command line. So, what are all the things that we can do with the WIRESHARK tool, okay, or other tools? We will also be introducing some other tools like TSHARK, etc. Okay, and if you want to install them, just go ahead and install. All these tools are available, many of them are open source and almost all of them are open source. So, you can go ahead and install it in your machine, and we suggest that you use a Ubuntu machine, not Windows, because all these tools are easily downloadable, and then you can just go ahead and install, and then since you will have administrator permission, even if the machine goes off, you can just get it recovered. One of the things that we would suggest that you also use a virtual machine to try out all these things, because if there is a problem, then virtual machines can be recovered much better than the real machines. Okay. Anyway, now we will do something on packet analysis. What we have been doing is that we have been capturing packets using WIRESHARK. And what do you do after capturing the packets? Okay. So, there are actually 4 activities that we can do. One is the protocol analysis. So, we saw that one of the fields that was shown by WIRESHARK was the protocol. So, we can do some kind of protocol analysis using WIRESHARK. Then we can also do packet analysis. Okay. So, what kind of packet, what is the data it carries, etc. Then we can also do multi-packet stream analysis, because if you take internet, okay, the packets actually traverse, okay, not as continuously, but in small chunks. Okay. The size is determined by what the routers feel should be their correct size. Okay. What happens is that if you just take 5 or 6 packets, they will be connected together, and that is called as a stream. Okay. So, multi-packet, and then we can find out what are say for example, a protocol like SIP, it has a control plane and a data plane which is separated, because when you dial a number, okay, so what happens is that the dialer goes to a separate server, and once the connection gets established, then the path that is taken by the data is different. So, if you want to collect a forensic evidence of VoIP, then you have to correlate between the control plane where dial things happen and the data plane where the actual talk gets exchanged. So, all these things, then you have to reconstruct these two together. So, these are all the fundamental things that you will do after collecting the evidence or acquiring the evidence. So, there are a lot of challenges in this activity. Okay. The first and foremost is that not possible to recover all the packets. Okay. And sometimes when you are collecting, you may not have collected it properly. So, the packets could have got corrupted, or it could have got truncated. The third possibility is that the contents might be encrypted. So, you might need some kind of encryption key to identify what encryption it is, and or decrypt the packets. Many of the service providers, not the content providers, actually use some undocumented protocol. Now, this is where the whole challenge arises. Okay. For example, WhatsApp uses its own encryption strategy, which does not let out, okay, what encryption strategy it is using. So, if a network forensic expert might have to crack these things with the help of hackers, or even if he is capable of doing it. So, that is the other problem. There could be undocumented protocols that are being used by organizations. Many organizations use these kind of undocumented protocols for security purposes. And the final one is the volume of data. I think we had discussed it about how much data flows through a router and how difficult it is to store all this data and work with it. First, let us see what is protocol analysis. Okay. It is defined as an examination of one or more fields within a protocol's data structure. A protocol analysis is commonly conducted for purposes of research, as in the case of unpublished protocol specification or network investigation. So, as I told you, if there are certain organizations which actually have unpublished protocol specification, we might have to decrypt it. One of the examples was AOL, America Online's chat protocol. Okay. So, it was a sort of proprietary, but people actually broke it. So, one of the things in network security is if you try to keep the algorithm closed, and people will try to break it. So, usually the algorithm becomes open, but the way you transfer the keys, etc., becomes closed. Okay. And the best practice is that to take cryptographic checksums of all data during collections. Okay. So that tomorrow after you decrypt, and then if you are able to find the encrypted key, you see that okay, the checksum matches. And as we had discussed earlier, and we had done it in WIRESHARK also in the previous session, you have to work with an exact copy of the original data intact. So that is why we actually store the data and then use it. For doing protocol analysis, which is the best place? So many of these protocols are published by the Internet Engineering Task Force. I think we had heard about it in previous sessions in Information Security 3 course. It is a large public repository of documented protocols. They have a structure of writing the protocols, and all these protocols are written in text files, so that it is easy for you to any editor to take a look at these kind of files. Okay. They are published as requests for comments or RFCs. These RFCs are regularly updated. So having except when it becomes a standard, they give a RFC number for it. Okay. For example, IP, TCP, all these have some standard numbers. Okay. But for other protocols, until the concurrence is obtained, so it does not, until it becomes a standard, then a particular number is not applicable. Other than IETF, there are ISO, then the International Institute, Institute of Electrical and Electronic Standardization, then IEEE is one place. Okay. But sometimes the IEEE documents you have to pay money to get the protocol standards. And the best place for searching all these things is vendors and researchers. What you can do is that there are many protocol analysis tools. Now, one of the things that you can do is WIRESHARK captures the packets in a particular format. I think we actually stored it as a PCAP NG format. There are some markup languages. Okay. One is known as the packet details markup language and the packet summary markup language. Okay. So these are the advantage of using PDML and PSML is that if you have a parsers for this, then you can write code much easier to identify and then automate many of these things. There is also this command line TSHARK, but we will just and you can actually convert WIRESHARK's file to PDML or packet summary PSML, etc. The PDML expresses packet details of layers 2 to 7, the ISO standard, OSI standard, ISO's OSI standard. It actually shows it in the form of an XML packet. So it is shown on the right hand side, that PDML, and then each one of this is a packet. And then one of the ways you can do it is that you can use the TSHARK tool and then read the PCAP NG file. So in this case, we have put a PCAP file as an example, and then translate it to PDML. You might have to write it to some files for XML, xml.pdml or whatever it is, to ensure that you can store these things. Similarly, for PSML, you can do the same thing. If you see -R is to read the file and then change it into this particular format, and then you can. So this is the structure of the PSML format. So the point is that you convert it to whatever format to which you are comfortable, and it also depends on what are you trying to analyze. If you are going to write lot of scripts, then converting to these format is a good idea. So TSHARK is similar to WIRESHARK, but it is a command line interface. So these are all some basic commands for TSHARK. So in case you do not have a command line interface available, so probably you can use TSHARK, and this has almost the same features of WIRESHARK, but WIRESHARK is much more easier to use. That is why we actually demoed WIRESHARK. So this is just given for your reference. If you want to try out this, you are welcome to go ahead and try using TSHARK. Essentially the functionality that is provided by TSHARK is also available in WINSHARK. So here is what TSHARK will display. We are given some examples. So one of the things that we have to do with protocol analysis is that so you see the kind of effort in one direction and the structure on the other direction, and then you have to repeat certain processes again and again and again. So it is actually a huge activity. The three basic stuff that you have to do is protocol identification, what type of protocol. If the protocol is well known, then you do not have a problem. If a protocol is not known, then you have to identify how the protocol works. So, that is done by protocol decoding, and then exporting the fields to establish the credentials, that this is what has happened. So, this chart that is presented in this location actually tells you what are all things that we need to file. So, you collect data from external data sources, you do sort of filtering. If you remember, we did the same thing with WIRESHARK. We actually collected all the packets. Then if you look at the top tab that we went through, we were doing a kind of filter, and then we store this filter and then search for information within that filter. If whether you would try to get a positive or a negative evidence, okay, and then finally you try to read and extract the data from those. For example, you would have looked at the metadata or the data protocol data that is there in the packets, and then you might have to go inside the packet itself, okay, to find out what is the kind of things that are happening. Actually, we will do a case study and we will see how these things are applied. So, before that we just have to understand how we are doing all these things. So after that you have to search for relations, and then that will become the evidence file. Then you have to organize it, there will be huge volume of this evidence file. Then you have to again include the structure. I mean, you might have to collect the metadata for this and then collect this as evidence, whether then you have to form certain hypothesis, okay, and then reevaluate the hypothesis, and then finally using correlation and other things you just have to prove that something. So, this is the work of a forensic expert. Okay. So, how do we usually identify protocols? Okay, I mean, usually the protocols will have some kind of signatures. Okay, say for example, marks like 0x4500 marks the beginning of a IPv4 packet. I mean, similarly a PDF document starts with a certain marker. Okay. So, in this way you will be able to identify, okay, what kind of protocol is going on in the network. Okay. So, sometimes for example, in SNMP they allow company specific management information. Okay. So, it will be then in that case you might have to identify that it is a company specific information and then go to the company's website to find out what information they are presenting. Okay. So, here are some ways in which the protocol can be identified. One is use information in the encapsulating protocol. So, for example, if the standard says that IP can encapsulate TCP or UDP, others also, but for the time being. So, now what will happen is that one of the fields will identify, okay. So, within the IP packet, okay, one of the fields will identify whether it is a TCP packet or a UDP packet. I mean, you can observe it in WIRESHARK. Okay. I think we showed one example of a UDP packet in WIRESHARK. Okay. The next one that I can do is I can look at port numbers. So, for example, port 443 is specifically SSH, okay, or TSL or SSL, secure socket layer protocol. Then 53 is DNS. These are known as standard ports. Okay. So, you could using these kind of standard ports you could identify what is the kind of protocol packets that are flowing in the network. The other thing that you can do is you can use the IP address and you use something known as who is lookup. I mean, so what you do is this is a public website. Okay. So, if I give a public if I give the public IP, it will tell you what is its domain name. Okay. For example, google.com, it has a particular public IP, etc. Finally, if you can't identify any of this, please take a look at the RFCs, because some people implement protocols, okay, which are not at a standard, but they find it convenient to use. So, these are all some of the ways by which you can identify protocols. Obviously, I mean, there are some known methods. You could also try your own innovation to find out other methods of identifying the protocols. Now, once I identify the protocol, if the standard is known, then I have no problem in decoding it. Okay. For example, a protocol, see the WIRESHARK itself has a decoder. So, here if you see this, we have a way by which you can decode the protocols. So, if you look at this, you go to analyze and then you go to decode as, then it tells you, I mean, how you need to decode this protocol, etc. So, you can use the publicly available automated decoders and tools and manually decode traffic with publicly available documentation. Now, what can you automate the process? Yes, you can. So, this is where learning some of the programming languages helps you. You could make yourself familiar with Python or Ruby. So, what you can do is, if I get to know the publicly available information of a protocol, so how the protocol behaves, then I should write a protocol interpreter in one of these languages. And if you write it in Lua, you can just straight away attach it to WIRESHARK, and then in that way it can be used, and you can also publish it as a documentation so that others can also use it. So, this is something you might have to work on when you are doing when you come across each problem. I mean, we cannot generally say that okay, you have to write these things. All well known protocols are documented already by WIRESHARK. So, we can use this. One of the things is, after this is that you have to download specific selected package bytes. So, this is just to establish something. Okay. For example, if I carry a document, then I have to download all the packets that carry a document. For example, I am sending a Word document from our organization to some other place secretly. I mean, hopefully without any encryption. I mean, so once I do this, what will happen is that then I have to select all those packets which carry this documentation. Okay. It will be carried as a payload, and then I have to only select those kind of documents and then put it together. So, here you can either use WIRESHARK to identify, or you can use a long command line. If you are a geek, then you try to use a long command line, something like this, okay, and then translate it to PDML, and from PDML you do a lot of work. So, this kind of translation can be done with TSHARK. For example, this is I use the PCAP file, and then I used a Lua script, okay, and then what I do is I capture from a particular frame number and then write it into a PDML format. So, in this way, once I write it in a PDML, then I can write XML parser, XML kind of parser to get the data and other information. Now, after I do a protocol analysis, I can also do a packet analysis. Okay. A packet analysis actually goes into the contents of the packets. Okay. So, it is examination of contents and or metadata of one or more packets. A packet analysis is typically conducted in order to identify packets of interest and develop a strategy for flow analysis and contents reconstruction. So, as I told you before, suppose I send a Word document, okay, the Word document will not be sent in one packet. So, it will be split across many packets. Okay. So, once I identify that in one of the packets I have a Word document, then I have to find out what are the packets that are sent before and then the packets that are sent after, and then I try to merge all these data together and then try to recreate the Word document that was sent. So, this is an example of a packet analysis. Similarly, even in packet analysis we can use WIRESHARK or TSHARK. Other than this, you might have to use some kind of hex editors. There are many of them available with Kali Linux, okay, and you can also use something like ngrep, etc. So, here is an example of how a WIRESHARK filter expression can be done. So, if you look, we had looked at filters, we told you that we can apply filters, and if you look at WIRESHARK, it has given almost I mean for almost many of the standard protocols it has display filters. Okay. Since WIRESHARK is also an open plugin architecture, you will actually be able to build your own protocol parser, okay, and you can also build expressions of your choice, etc. So, here is an example of how to use TSHARK also. So, here it tries to identify all those packets with IP source address as 192.168.1. something. Okay. So, as I told you, ngrep can also be used. Okay. It looks for packets based on particular, similar to grep. I think if many of you are familiar with grep, fgrep, egrep and all those things, ngrep is used to work on PCAP files. Okay. So, here is just like grep. If you are familiar with grep, you should be able to understand about ngrep. Okay. It recognizes the common protocols and it tries to extract the strings that are present in any of these common protocols. Coming back to hex editors. Okay. So, there are these types of hex editors that are available. Okay. The hex editors actually manipulate this can be for some kind of advanced forensics, because these hex editors work at the range of bits and bytes. So, you should want to do something known as a file carving. So, you might have to build these kind of hex elements, put them together, and then if the packets are fragmented, then which is the header, which is the byte and which hex byte should come here and so on. So, It is a sort of detailed analysis for which you will be using all these things, and one of the example is most tools will not see inside a compressed file. So, in that case you might have to look at this hex, then take the compressed file out, then decompress it and so on. Some of the packet analysis techniques includes, one is pattern matching, and then parsing protocol fields, and then packet filtering. So, pattern matching is similar to ngrep, okay, where you search for a particular pattern. We also saw that how to parse protocols fields, because protocols fields are given certain length, for example, IP is 20 bytes header, IPv4 20 bytes header and so on, and then you might have to filter the packets to identify what type of packet it is. So, here is an example of a pattern matching. For example, I can use ngrep, then I can look at the strings, the names, patterns. Most of you are familiar with grep. I think you should understand what this is, because ngrep, you take the evidence file and then search for the words that you want to say, and the output will be displayed for a particular packets could be displayed where it is available. So, similarly for parsing protocols fields, you can use TSHARK or you can use WIRESHARK straight away. So, with TSHARK you might have to give all these command line parameters, etc. And with packet filtering, okay, it is art of separating packets based on the values in the field in the protocol metadata or payload. Okay, one of the tools we can use is TCP dump, okay, with Berkeley packet filter. I think we discussed this in the one of the previous sessions. So, TCP dump can be used to dump the packet, and the best tool we suggest is WIRESHARK. Okay, so, this brings us to the end of this module, where we are looking at packet analysis. Thank you.